Good morning, everybody. Welcome to the workshop Learn Analytics and Machine Learning with Red Bull Racing. Today is all about learning some new skills around analytics and machine learning. We've got some presentations for you lined up, but above all, this is about you getting hands-on with data from the races and actually solving some analytics challenges by yourself. Don't worry if you don't have any experience with this, with analytics or machine learning, or if you don't know the tools, because you're going to learn everything as you go. And by the end of today, you should be able to apply those new skills to many other problems, whether it's in sports, in business, or even in your personal life. So these are very, very useful skills to have. Okay, I'm the guy here on the top left. My name is Jeroen Kloosterman. I'm in the product strategy team of small and medium business here at Oracle. And my co-presenter will present herself.
Hi, everyone. So I'm Nada Magid. I'm a senior domain specialist specialized in analytics, connecting with you from Egypt.
Great, Nada. Okay, there's a lot of other people that have been helping getting this workshop ready and that are also here behind the scenes right now. A special thank goes out to Mark Philippe, who's been helping also to create the content, but also everybody else here has been helping in one way or another. And a lot of these people are here right now to help you, the audience, while you're doing the exercises. If you have any questions or you get stuck, these people are here to help you to get unstuck again and to continue. Okay, so Nada is going to explain some things about how we're using Slack.
Right, so we're going to be using Slack for the purpose of communicating for your questions, for chatting, rather than having the chat there. So please click on the link on the slide and join our Slack channel. And please let us know where you're connecting from. Tell us where you are in the world.
So while you guys put your hello messages in there, I'll give a brief introduction of what we're going to do today. So yeah, the goal is all that you learn about analytics and machine learning today, because with data, you can understand things better. You can ultimately make better decisions about basically anything. And this part basically provides a great learning context for you because it's so data intensive. And you can use data and analytics to gain a competitive edge as a team. And many teams, of course, or all teams are doing that. But you can also use analytics and machine learning in different ways. So for example, you can put data to good use to find out how the sport as a whole could be improved. And that's what we're going to focus our attention on today. So imagine that our goal is to make the sport as interesting as possible, even more interesting than it already is. So what do I mean with that? Well, sometimes you sit down to watch a Grand Prix and it's so exciting that you can't stop watching. I think you know the feeling. It's sometimes a race that you never forget even years later. And sometimes you sit down to watch and not so much is happening. And even if you go for a walk in the middle of it, you wouldn't really miss so much. So that raises the question, what is it really that makes a great Grand Prix? What is that factor that sometimes you're literally on the edge of your seat, and what adds that excitement? So that is the question that we'll try to answer. And I'm sure you have some things in mind yourselves, right? So it's the amount of overtakes, or it's great if it's raining, that always adds to excitement. But we want to go a step deeper than just to have a gut feeling, right? We want to really get to the bottom of this. We want to go so far that we're actually able to score how great each Grand Prix is in a numerical way. Because if we're able to do that, if we're able to put like science into this question, and we are able to actually predict what the score of a race is, we will have proven that the model that we've used to do that and the factors that have gone into the model are indeed the right ones. And then we also know that those factors are the ones that we actually have to work on to try to make the race better and the sport as a whole. So I hope that gives you a sense of what we're going to do. We're going to need analytics, we're going to need machine learning. So take this challenge with us and find out what makes a great race and find out how we can make this sport even better. Okay, so this is our agenda. We start with preparing your cloud environment. So that's very important. This is where you're going to do your exercises. You'll need an Oracle Cloud infrastructure account, totally free for use for a month. You'll need to set up some services in there, the Autonomous Data Warehouse and Oracle Analytics Cloud. So we'll first go through that. And while we do that, while we kick off that process, then we go into some presentations because that process takes some time. So those are 2 short presentations. And then you get into the actual exercises. So you're going to load the data that you need into the Autonomous Data Warehouse. Then you're going to do data exploration. And that's very important. You're going to try to find out what factors you think are important, because those are the ones you're going to select to later train a machine learning model on. And that's in this last lab where we do feature generation, training the machine learning model. We evaluate it and we visualize also the result. Okay, so we're going to start there. And the first thing you need to do, and we already asked you as well actually for this, to create an Oracle Cloud infrastructure tenancy, so your own cloud environment. Now, I'd like to launch a poll to see how many people have actually done that, or is there also a portion that hasn't done this yet? Yeah, so about 2/3 have done it. Thank you very much. But about 1/3 hasn't done it yet. So I'll just quickly want to show you what you have to do for that. So, so this cloud trial, normally what happens if you request a cloud trial yourself outside of a workshop context is that you'll be asked for a credit card number. Now, that can be a little bit difficult in some cases. So what we've done is we've taken all the email addresses of all the people that have registered and we've whitelisted them. So that means that if you go to this URL and you ask for your cloud trial, you will not be asked for a credit card. And that can be very convenient, of course. If for whatever reason you're not able to use that email address for which you've registered on the workshop, if you can't use that for the Oracle Cloud for whatever reason, maybe you've already used that email address before, don't worry, send us another email address, send it to Nicole on the chat, or just type a message and the people will find it. And we can whitelist another email address for you on the fly right now, okay? So the people who haven't done it yet, please go to this URL now and follow this process. In the meantime, I'm going to play a video of how this whole process goes. And immediately after, I also play a video that I recorded earlier on a bit more detail on the challenge and on the basics of machine learning. So that's also important to watch. Okay, guys, so we'll speak in about 10 minutes again.
Hi, I'm Victor Martin from Oracle Cloud. I'm going to walk you through the steps to sign up for an Oracle Cloud free tier. Please follow along and pause the video when you need it. Oracle Cloud free tier gives you a set of always free cloud services. These services will be available forever. 2 autonomous databases, 2 virtual machines, up to 4 ARM processors virtual machines. You will also have a load balancer, block, object, and archive storage, monitoring, and much more. As part of your Oracle Cloud free tier, you will also have a 30-day trial with free credits to use in other services from analytics to Kubernetes. Sounds good, isn't it? Are you signing up for an upcoming workshop with us? Please make sure that you use the same email you use for the registration, as we have activated a special offer and you won't need your credit card to sign up. In any case, Oracle Cloud is not going to charge you for your trial. You actually have to explicitly tell us so when you are happy with all the Oracle Cloud services after your trial. Let's dive in. You need to add your country, then your first and last name. You also have to provide your email. Oracle Cloud has to check you are a human by asking you to resolve an easy challenge. Finally, click Verify my email to move to the next step. If your email has been activated for the offer, you will see the special Oracle offer pop-up window with the type of offer already selected. Then click Select Offer. All the initial information is already in. Now you have to provide a strong password. I use a generated one but you can select any you like. Just make sure you are in compliance with the strong password pattern. Confirm the password by typing it again. Fill the company name if apply. The cloud account name is essential as it is a unique identifier for your account. Select a name you like that is not taken. The home region is the region where you are more likely to deploy resources. You can deploy to other regions by subscribing to them. However, your free trial only supports one region. Select a region geographically close to you if you are not sure. I'm selecting Frankfurt region. At the bottom, click Continue. Fill the address information with city, postcode, county, and your phone number. Click Continue. The final step is to accept the agreement and click Start my free trial. Oracle Cloud starts provisioning your account. This takes on average 1 minute or 2. Then you are going to be redirected to the Oracle Cloud web console. Can you see the message "Your account is currently being set up"? It means that some services will still be unavailable for a few more minutes. Just keep it in mind. After a while, the message saying that your account is being set up will disappear. After a few minutes, you will also receive a Getting Started email and another one when your trial account is fully provisioned. Use the button in the email to sign in whenever you want in the future. You are all set up to enjoy your new Oracle Cloud account. Happy hacking!
To work on the challenge, you require a basic understanding of machine learning. So what is that exactly? It's basically a collection of different algorithms that let you find patterns, find anomalies, and make predictions on typically large amounts of data. So data is the key to machine learning. I'm going to focus on a particular part of machine learning called supervised learning. And in supervised learning, the idea is that you train a model from a lot of example data. And then you use that model to predict what's going to happen next. To illustrate this, I always like to use the example of house price prediction, and we'll come back to the raising context in just a few minutes. So let's say we want to predict the price a house will sell for purely based on its size. And we have all this example data of houses that were sold in the past. We know their size and the price they were sold for. So we can plot this in a chart. On the vertical axis, you see the house price, and on the horizontal axis, you see the size of the house. Simply put, training a model is about fitting a line that best presents the pattern in the data. In fact, that's exactly what the linear regression algorithm does. It tries to find a straight line that best fits the data. This line is basically our model. So when we have found the function or the definition for this line, we can say that we've trained the model. Then you can go to the next step, which is making a prediction. Let's say we have a house of 200 square meters, and we would like to know what price it is likely to sell for. Our model will now tell us that the house is likely to sell for about 400,000. So you see how a model generalizes from example data, often historical data, and is then able to predict the values for new data. Now, of course, this is an oversimplified example. In this case, we only had one input feature, the house size. But in practice, you'll train models that look at multiple variables like the number of floors, whether the house is a garage, the neighborhood of the house. So then you can imagine that the resulting function becomes a lot more complex, and too complex actually for a human being to find. But the idea is that, generally speaking, the more relevant data you can give to the algorithm, the more information about each house, the more accurate the prediction will be. So now let's come back to our raising challenge. Our goal is now to identify the factors that will make a great race. We have race data from 1915 until now. For example, for each race, we know its location, the date, the number of overtakes, the weather, etc. We also have a fan score per race between 2008 and 2020. The website racefans.net collected this average race score from thousands of fans, and we'll use this number as our ground truth of exactly how good a race is. So our first job will be to think of candidate factors that we think or that we suspect may be related to the score of a race. For example, the number of overtakes, the weather situation, or the actual circuit where the race takes place. Now, for us as human beings, we may have some gut feeling of what factors may be important to predict that race score, but it's really difficult for us to quantify exactly how those factors influence the score. Certainly when there's many factors at play. So that's why instead we will use the power of machine learning to try to learn what those relationships are. So the idea is that if we can show that we can accurately predict the score with a machine learning model, then we also have solid grounds to say that the factors that we train this model on are indeed the right ones. We will go through two phases. In the training phase, we will take all the data that we have until the end of 2019 and train a model on it to find out how exactly score is influenced by all those factors that we've identified. And once trained, you can see that model as a thing that understands the relationship between all of those factors and the score. So then once we have that model, we can turn things around. Then we will take the year 2020 and we take all the data that we have on the races, all the same factors, and then we use the model to predict the scores for that year. The interesting thing is, for 2020, we're making predictions of the race scores, but we also have the actual ground truth fan scores for that year. And because we have both values, we can compare them. Here you see the end result that you'll try to create yourself. Our ground truth, the actual scores of the fans, they are in blue, and the predicted scores by the model are in green. If you manage to get through all of the steps of the labs, then you should see a very similar result. And you'll see that the actuals and the predictions are pretty close, which is an indication that our model is accurate. And once you have that, you could actually use this model and predict the scores for the races of 2021, for example. We don't have the actual fan scores for 2021, but that doesn't matter because now we can trust the model and we can trust that the predictions will be pretty accurate. And most importantly, we now will know that the factors that we've chosen to train the model are indeed the right ones that we should be working on to try to make races even more interesting. So guys, this is the challenge. I hope you're able to produce a similar result as what you see here on the screen. Okay, guys. So I hope that gave you an impression of what the challenge is. Now we're at the point that everybody should have their cloud trial, their cloud tenancy. And the next thing you should do is go to the rest of the lab instructions. So you see that here at the left bottom. Please go to that URL. Okay, and I will also open it right now and show you how that looks. So here are all your instructions for the rest of the workshop. And the first part we've already done, which is creating a cloud trial. And what we start now with is lab 1 and 2. So that's what you're going to do now. You're going to provision Analytics Cloud, which is basically where you can make all these very nice charts and these visualizations. And Nada will talk a bit more about them. And lab 2 as well, provision autonomous data warehouse, where you're going to store the data, and that the heart of the machine learning is also there. So for those steps, guys, I'll show again this. So go to this URL. That's where you find the instructions and go through these 2 labs. And you'll get just a little bit less than 10 minutes for this exercise. So about 10:32 CET, we'll start again with a little presentation by Nada on what these 2 services do exactly. Good luck. Yeah, one thing, everybody, you don't have to wait for the revisioning of Analytics Cloud to complete before you continue to Autonomous Data Warehouse, okay? Just kick off the provisioning and let it run in the background, and then you continue to lab 2.
Hi, everyone. So before we let the race begin, so to speak, I just want to give you a quick overview on the services that we're going to be using for the purpose of today's lab, right? And basically what each of them brings to the table and what each is comprised of, right? So with that being said, this is just to give you a global view on how they come together. Those 2 main services that we're going to be using are the Autonomous Data Warehouse, which is going to be covering the machine learning side of things, right? And essentially, data is at the heart of machine learning. And we have almost 70 years worth of data in this practice. So it definitely makes sense to have that data warehouse to store the data in. And then the second service, which is the Oracle Analytics, this is going to be our visualization platform, right? Before jumping into machine learning, there's a lot of, let's say, qualifying, to use the term correctly, that has to be done in the back end for the data to be ready to be used for machine learning purpose. So visualizations help kind of move things along in that regard. So we're just going to dig a bit deeper into each of those services, and starting off with the Autonomous Data Warehouse. So what is the Autonomous Data Warehouse? It is essentially Oracle's latest database version running on infrastructure that is primed for analytical processing, right? That is its main purpose. One of the main features is that it has automated data management. So it intelligently, automatically configures, tunes, updates your data warehouse without any manual intervention. And with that, you eliminate the possibility of human error, right? So you have more time to focus on what you need to achieve rather than the management side of things. You are guaranteed consistent high performance because of the automatic table indexing and tuning, and also the ability to auto scale. So with auto scaling, you actually get an increase in compute as well as IO, up to 3 times the initial amount, just to satisfy the needs of the workload. And then it goes back down accordingly when not in use. With that, you suffer no downtime at all. And that's a huge advantage, right? Typically in that scenario, you definitely would have to suffer downtime. You also have the comprehensive data privacy and protection, because data is always encrypted, whether in transit or at rest. And the patches are automatically updated for you as well, so you're guaranteed security. And last but not least is that it is a complete solution that has built-in analytics, right? There are built-in machine learning algorithms that are provided for you, along with graph analytics and spatial support. So we are truly empowered to make use of the data warehouse, right? And typically with these large amounts of data, there is an issue if you have to move the data to an analytical platform. But in this case, we're moving the analytics, the machine learning to the data, right on top of the data. And then we can start to visualize those insights at a later point in time, right? So you're guaranteed reliability and security in one shot, in one single place. So next we move on to the Oracle Analytics. And I like to think of this as a one-stop shop, right? Sort of like a mall, where in a scenario you need to run some errands, you need to do some grocery shopping, do some transactions at the bank, get some stuff from the pharmacy, drop your kids off at nursery while doing all these things. So in a typical scenario, you'd have to go to all of these different places. You spend time, effort, money. But with the option of a mall, you get to do all of this from one single place. And this is the same idea when it comes to Oracle Analytics, right? You can start to connect your data from a variety of sources, whether they may be databases, Excel sheets, CSV files. You can then start to prepare or modify that data. Maybe you want to do some semantic modeling as well. You are truly enabled to do that. And then you can start to explore that data through the different visualizations that OAC has to offer, as well as some machine learning capabilities as well from OAC side with one-click advanced analytics, right? Once you're satisfied with your content, with your dashboard, then you go ahead and share that content, either by exporting it in, let's say, PDF or PowerPoint format, or even better yet, you can actually embed that content into web applications or mobile applications. And regardless of the type of user that you are, so technical, not too technical, whatever it may be on the grand spectrum, you are truly empowered to make full use of the features that OAC has to offer, right? And whenever we specifically mention the term machine learning, one starts to think, well, that needs someone technical, right? You need some programming expertise like Python or SQL. But what Oracle Analytics really has to offer is that you don't need any of that because it's just that simple, right? And from there, you can preach your heart's desire, really, and the sky is your limit. So I hope that's given you a really good idea of what the services have to offer, what they're about, and happy racing.
Okay, so by this time, if all is well, you should have your Oracle Cloud tenancy. You should have at least kicked off the provisioning of the Analytics Cloud service. And with a bit of luck, you should already have the autonomous data warehouse ready to go, because that's usually pretty quick. So if at any point in time, guys, it takes you a little bit longer or for whatever reason, or you can't follow the exact speed of the workshop, don't worry about it, because all of this material is available afterwards. You can keep going to the exercises, so you can do it at your own speed. And also we'll have a recording ready as well. So don't worry about that at all. And of course, you'll have your cloud environment as well to continue working. So now we're going to take all the data that we need for our challenge, and we're going to load it into autonomous data warehouse. And again, you'll need to do that in the lab instructions. So that's the URL on the bottom left. And this time you go to lab 3, okay? And the summary here is that you first will create a new database user called the F1 user, right? And in that F1 user, you'll be putting all of those tables with the data about the races, the results, the rankings, the pit stops, etc. You'll be loading that. So you'll have about 8 minutes for this exercise. I think it should be enough. So good luck with it. And as always, we are there on Slack to help you if you have any troubles. Okay, guys. Now we're going to get to the fun part. So I hope you all were able to create your services and you've been able to load your data. If you haven't, as I said, you can do this at your own time and just keep following. Just continue slowly from where you are to catch up. So now we get to the fun part, as I said, and we're going to build some visualizations. So remember, our goal is to build a machine learning model. Can we just throw any data in that machine learning model? No, we can't. Garbage in, garbage out, I would say, holds true in this case. So you have to be very careful about what data you select to train that model on to predict the score. Now, what way can you do that? For example, you might have some hypothesis of which data points hold some relationship with the score, and you have some ideas in your mind, so you can test those hypotheses. Another way of finding data points is actually just visualizing the data that you have, and then let those visualizations inspire you and give you clues about what could potentially be data that is of value for your predictions. So that's what you're going to do during data exploration. Again, so you have OAC now. First, you need to create a connection from OAC to ADW to be able to access that data there. You're going to add that data then into Oracle Analytics Cloud. So you make it available, and then you get to that actual investigation that I just talked about. So that's it. Again, all the lab instructions are here on the URL here on the bottom left, and you're at lab 4. So good luck with that one. And this is a big exercise. Okay, so we're going to give you 30 minutes for this because there's a lot to do, and you'll use all kinds of visualization techniques like correlation diagrams and box plots to verify that the data points that you're looking at indeed have some kind of relationship with the score. And that's going to take a little bit of time. So you've got 30 minutes in total. And as always, we're there available for you in Slack with any questions that you have. Good luck. Hi, guys. I just want to give you a quick idea of the kind of end result of this lab, what you're going to work towards. So your goal is to test, let's say, the hypothesis you have of which data points might be relevant for the score. You want to test that out. You want to see if there's a correlation there at the least. So one way you can do this is with correlation diagrams. The goal is to test the correlation between the score and the total number of overtaken positions. So I can take score, overtaken positions total, drag it here to the canvas. Now it's only drawn one single point, but I want 1 point for each race. So I can take the race, move this here to category. So now we have the score here on the vertical axis, overtaken positions total on the horizontal axis. And each point is a race, so a combination of these two, right? So you kind of already see this, yeah, this trend going up diagonally, right? From bottom left to top right. So let me actually add a trend line for that. Yeah, so what that tells us that generally speaking, the more overtaken positions there are in a race, also the higher the score tends to become. Yeah, so yes, there is some kind of correlation going on there. On the other hand, you also see that these dots are not concentrated on this line, right? There's a lot of dots that are further away from this trend line, and that indicates that the overtaken positions certainly is not the only factor here, right? We're still missing information, so it will not be enough to predict score accurately to only have the overtaken positions, right? And that's of course the idea. Various factors have some kind of influence, and if we combine a lot of them, then we hope to get closer and closer to the actual score. Okay, so we've done this here now with overtaken positions. I could do the same here for the number of cars that don't finish, the DNF count. So let me just drag this over overtaken positions. And you see, you get something similar. Here, the correlation is a little bit weaker, it seems. The line is less, it goes up less as the number of DNFs go up. And so here the reasoning could be, yeah, the more cars don't finish, then apparently something has happened, an accident or some kind of spectacular thing, right, happened on the track. So that could indeed explain this positive correlation with the score. So you can use these scatter diagrams, or these correlation diagrams, as we call it in this case, to check the correlation between two continuous variables, as we call them. So score is a number, right, from 0 to whatever, and DNF count is as well. Now it becomes a little bit different if we want to compare with a categorical variable. For example, rain, yes or no. It has rained, yes or no, during the race. And that looks something like this. So for that, we can use a box plot, right? So here we have on the horizontal axis, we have it didn't rain with a no, or it did rain with a yes. And for both, we display what's called a box plot. So what does this tell you? First of all, this line here in the middle, that's exactly the average amount of races that it was raining or that it wasn't raining, right? And these are sorry, the average score of races where it didn't rain and the average score of races where it did rain. Yeah, so you see already that on average it appears to be quite a bit higher for rains where it, or for races where it does rain. That can be more spectacular, right? If cars spin around and all these things, and it's a lot less predictable, and that I think that adds to the excitement in general. But then again, we also see a lot of outliers outside of these boxes. So there's a lot of races where it didn't rain and they have top scores here. You see that? So like there's here one with a score of 9 and it didn't rain. So again, just this factor of whether it rains or not is certainly not enough to predict the score by itself. But again, if we combine several factors, we hope that we can get close to an accurate prediction. Okay, so this is data exploration, guys. using visualization to find relationships and to test hypotheses. Like, yeah, what is this variable, or is this factor of importance to predict the race? And you can test that with visualizations. So I hope that makes sense. You have a bit more time. I think you have 15 minutes more to do this yourself. So again, we're there in Slack for any questions that you might have. Okay, everyone, I hope it's all going well for you with the labs. So now I hand the word over to Nada, who's going to show you and demonstrate an advanced form of data exploration. Nada, over to you.
So just to recap on what you supposed to have done so far with regards to the previous lab, you were going through the data, which somehow has, let's say, readily open data points. They're available. We went over things like the number of overtakes, the did not complete, and the weather. But in practice, there's actually some hidden data that would add more value in a predictive situation for purposes of machine learning. So it's up to us to uncover those patterns to be able to make a prediction that is of value, that would contribute at the end of the day. So what we're going to do for this lab, and I'm going to be demoing this lab since it's more of an advanced data exploration. So just to have you in sync, we're going to go over some deeper, let's say, data exploration to come up with some hidden insights, hidden patterns from the data. So you created a number of projects from the previous lab, and the one that we're going to be coming back to is the race analysis. So we're going to go ahead and open the race analysis. And first thing I'm going to do is I'm going to update this filter right here, and I'm actually going to remove one of the options. So I'll just click on this, and I'm going to take away the 2020 Abu Dhabi Grand Prix, and we're just going to focus on the Brazilian Grand Prix. So once that filter takes effect, we're going to focus on one actually of the drivers here. So we're going to be focusing on Vettel. So once I've selected the name from the legend, you can see it highlights that line chart there. And we see that something happened at the very beginning of the race that kind of pushed Vettel to go back into the 22nd position. But all throughout the race itself, we noticed that he's done quite a comeback and ended up landing in 6th position, which was actually enough to get him to the championship for that year, right? So what does that mean? So generally, when there's a comeback, obviously that's of interest to the viewers, right? But it's even more interesting when we notice that the driver has come up a number of consecutive positions throughout that race. So that's something to make a note of, right? That when there's a comeback, when there's an advance in positions, that can most probably positively impact the score that a viewer would give to that race. So that's sort of one of the first insights that we've reached that was initially hidden from the main data, right? So next thing that we want to look at is maybe take into consideration pit stops and how they would play in the progression of the race itself. So what we're going to do is we're going to actually first we're going to change the race. We're going to look at a more recent race here. So we're going to change this to the Austrian Grand Prix. So let me just type that in the search bar. There we go. And then once we've made that update, we're actually going to add in the pit stop into the shape section. And we're going to see two shapes coming up where we have the square signifying that the driver has made a pit stop, and then the circle represents the driver basically being in line in track. And we're going to focus on one of the racers. So we're actually going to focus on Norris right here, highlighting in the legend. And we see the two racers that sort of overlap with Norris are the one in green right here, which is Bottas, the one in orange, which is Hamilton, right? So this is where they kind of intersect at some point during the race. So if we focus at around lap 30, we see that there was an overtake by Bottas to Norris, but we also noticed that Norris actually made a pit stop at that point. So obviously something interesting when an overtake happens, but it's important to note that there was a pit stop here where when we compare it to, for example, in lap 20 right here, there was an overtake by Hamilton to Norris and there was no pit stop. Nothing happened in that part. So this kind of brings us to the notion that there are two types of overtakes within a race. There's one that happens as a result of a driver doing a pit stop, and then there's another one that happens purely on the racetrack. So it might be of value to note that there are two types, and in general, it is more interesting when there's an overtake on the racetrack itself rather than when there's a pit stop there. So that's our, let's say, second hidden insight that we've managed to uncover from that data. So next thing that we want to look at is how do the drivers do in comparison to each other? So obviously we've been seeing this from a position standpoint, but that doesn't really explain from a time perspective how far away they are from each other in terms of seconds. That's not visually available at this point. So what we want to do is we want to add a calculation to kind of factor in that time component in a visual way, right? So first, we're going to update that filter again, and we're going to go back to the Brazilian Grand Prix. So let me just go back to the selection. There we go. And what we're going to do is we're going to add the calculation, right? So we're going on the left pane right here where we have the data. We right-click calculations and click on add calculation. And we're going to be dragging and dropping the median millisecond cumulative onto the section for the calculation, add the minus sign, and then drag in the millisecond cumulative. And we're going to be calling this the delta . Right. So we're going to be introducing the notion of a delta ghost car, right? And the ghost car here is meant to represent the average time for the entire pack, the average time that it takes for the entire pack. So that's supposed to be sort of like our median line right there. So we're going to be calling this the delta ghost car. So let me just add that to the name, delta to ghost car. And we're going to save this. Right. And we're going to be creating a new visual. So let me just take this off so that it's more clear visually. And we're going to be taking in the lap, the driver reference, and then the delta to ghost car. Missed that. There we go. Right click, and we're going to be picking a visualization, which is a line chart. So our y-axis is going to be that delta to the ghost car. Our x-axis is the lap, and then the color reference is the driver, right? So the horizontal axis here, where y is equal to 0, that's our ghost car right there. All of the lines that are above are actually moving at a faster pace than that ghost car. And then anything that's below is actually slower. And if we focus a bit in this area right here, at laps, let's say 25, between 25 and 30, there's an event that happened that brought all those cars closer together. And most likely what happened is that the safety car was deployed. And this is quite interesting because when a safety car is introduced, it kind of resets the status of the race because all the cars have to come together at a very close distance. And then it's sort of like it starts off all over again with the race continuing after the safety car is deployed, right? So that's sort of the third hidden insight that we've managed to uncover. So just as a quick recap of what we've managed to identify from this is that we are aware that there are some hidden gems, so to speak, in the data that we can definitely make use of when we add to the data set to be able to make the most value of our machine learning model. And we've managed to come up with 3 main insights from this practice. First is the fact that overtakes, in especially when there's a huge comeback, can positively impact the score that a viewer would give to a race. And then second is the fact that when you have an overtake, there are sort of two types of overtakes. There's a real overtake that happens on the track itself, and there's sort of a semi-overtake that happens when there's a pit stop. So what might be of value to be able to identify those two types on the level of the data. And then third is the introduction of a safety car kind of resets the race. So with that, there's possibly an impact on the score for the viewer to the race. So I hope that kind of brings everything together. And Haroon, back to you.
That was great, Nada. Thank you very much. Okay, let me share again the screen on this side. Yeah, so now we finally get to the actual machine learning after all of this preparation and this data exploration. So that's what's going to happen in the next lab. So Nada showed that she found all these potential gems in the data of additional data points that may be of value, right? So we've identified, apart from the total number of takeovers, and what was it, the weather, we have this thing like the comeback score, and what else, like pit stop or takeovers versus normal takeovers, etc., and a few more of these data points. So we've just identified them. The first thing we now need to do is actually extract those new gems, okay? And that's what we're going to do in the feature generation. Once we've done that, we're going to actually train the machine learning model. And we're going to use a thing called AutoML, which is going to make our life a lot easier. We don't have to know a lot of the complexity behind it. Once you've done that, you have the model and you can predict the scores. Now, remember, in the introduction, I said we're training on the data until the end of 2019, and we're going to predict the scores for 2020, because that will allow us then to later evaluate the scores of 2020. We're going to compare the predictions against the actual values that we have for 2020 to see how accurate the model is. So these are the steps you're going to take. Let me just quickly show you a few things of how that looks. So so you know more or less what you're going to be doing. So okay, let me just turn off the camera here. Yeah. So this feature generation, that's something we've basically prepared for you. So remember, Nada said we have a thing called the comeback score that we want to calculate. We want to calculate how many takeovers are a result of pit stops and how many actual takeovers on the track there are, etc., etc. So in this notebook, which you're going to open in just a second, you'll find all the instructions of actually extracting that data. Now, you know, the content of this goes a little bit too deep technically, because these are actually quite advanced of extracting that data, and that could be the topic of a next workshop. But basically, for your understanding, that is what is happening here. Okay, so all these additional data points are being extracted. Okay, then we're going to train the machine learning model, which it was all about, right? And this is the interface you get for that. So this is called AutoML. It hides all the complexity behind the scenes. And basically what you do is you say, this is the thing I want to be predicting. Okay, so the score, that's what you want to be predicting. And these are all of the data points that the algorithm should try to find a relationship with, right? So the weather, whether was a safety car on the track, which circuit it actually took place on, etc., etc. All these data points that we've been investigating before. So now all our hard work is going to pay off. This will result in a model. Okay, then we've done that, we go back into Oracle Analytics Cloud, and there's this concept of data flow. And data flow allows you create a little flow like this, like you see here on the top, that allows you to manipulate data. Okay, so in goes the races for 2020, because we're going to filter only on 2020, as you see here. Yeah. we're going to apply that model that we've just trained. So after this, in this data set that comes out of it, which we're going to call predicted scores. Well, I'm not sure if you call it actually like this in the exercise, but it's something like this, predicted scores, I believe it's called. In that data set, you will have the actual value that the fans gave it, and we will have the predicted value. Okay, so, and then after you've worked on this exercise, I'll show you what the end result is, and hopefully you're able to achieve that yourself as well. So that's it. Again, this is quite a bit of work. So in this case, we're going to give you 20 minutes. And yeah, let us know if you have any questions on the Slack. Okay, good luck, guys. There's a question here from somebody who says that he's training the model with AutoML and he's getting slightly different error scores or a different predicted accuracy of the model. Well, that's likely to do with that maybe you chose slightly different columns to train on. There may also be a small difference simply because of a factor of randomness, but it shouldn't be a huge factor. So it should be a few percent only maximum. Most likely, yeah, you did just something slightly differently along the way. In any case, I would just recommend to continue because it's really about you seeing the process. And even if the model is maybe slightly less accurate, that's not such a big deal. At least we want you to see the end result, right? That you can make predictions with this. The goal is not to reach perfection here, right? So yeah, thank you. Okay, guys, so it's 12 p.m. So it's time for me to come to some conclusions and to wrap up. And first of all, let's go back to the end result that you should be getting. I'm not sure how many of you actually managed to get here, but this should be your end result. Okay, so in blue you had the score here for 2020 given by the fans on racefans.net, and in green we have our predictions. So you see that it follows that pattern pretty nicely. And also here we've calculated what the difference is between those predictions. So for example, here, especially here where the actual score is a little bit on the low side, the prediction seems to be a little bit off. And of course, this is a process, right? Machine learning. So we can look for additional data points to see how we can make this prediction even more accurate. Or maybe we have some kind of data errors in our existing data points and we can, this is a process. It's like a circle of ever improving and trying to get this thing more accurate. So why did we do this for 2020? Because we already had the actual fan scores. Well, this was just a mechanism for us to verify how accurate it is. And now we know we can put some trust into our model. So we can also use it for years for which we don't have the actual fan scores yet. So let me see. I made the predictions here for 2021 as well, for example. For that year, we don't have actual fan scores. And the data here goes until the Hungarian Grand Prix actually that we have in here. But now we can make those predictions and we can be fairly certain that these should be the overall impression of fans about these races. I mean, there's something great, right? We haven't even asked the fans how good they think the races are, but we can already be pretty sure that this will be the overall impression of an audience about those races. So what do you think yourself? Have a look at these scores of these races. Do you think this is accurate? Do you think the Hungarian Grand Prix was a pretty good race with a score of 8, for example? Yeah. So that's the power of machine learning. And well, I hope you see that, and I also hope you see that you could be using this for many more scenarios. So let me just wrap up a few more things and open the presentation here again. Yeah. So just to come back to what our original challenge was, we wanted to get an accurate model so that we could show that the factors that we use to train the model are indeed the right ones. Remember, what goes into this model? Things like the takeovers, the weather, whether there's a safety car on the track. And now we can say with some, a decent amount of certainty that these are the right factors. So now we can work, for example, on the takeovers. What could we be doing to have more takeovers in a race, right? So that's a topic, of course, in itself, but we know that's important. The weather was important if it's raining. So now we could say, so instead of canceling a race when there's a lot of rain, for example, maybe the organization shouldn't do that so quickly because it gets higher scores in general. Or the safety car, that's another one in general that leads to higher scores. So maybe we should deploy those safety cars a little bit more often. So lower the criteria for when a safety car needs to be deployed. Of course, this is just a starting point, but I hope you see how machine learning helps us to make decisions and to improve things or to improve the sport in this case. I also hope you see that normally machine learning is a very complicated thing. So you need statistical knowledge, you need technical knowledge, programming knowledge, things like Python skills, but we haven't really used any of that here. And the tools, Analytics Cloud and Autonomous Data Warehouse really made our life quite easy. So that's it. I hope you finished it or that you will finish the challenge. And I hope you will use your newly learned skills for new challenges. So then, if you want to learn more, there are some events coming up. So there's one on October 21st in this Red Bull series where you can use machine learning to predict the winners of the next race. There's also, so that's an actual live event, right? There's also an on-demand event, which you can do at any time, called Introduction to Data Science. You can use this URL that you see here. And maybe John could be posting these links on the Slack channel. So I think he's doing that right now. So this is really an introduction. It goes a lot deeper into machine learning theory and everything, the theory about data science, as well as some products that you can use for this. So if you're interested, you can go there. And there are two more events. There's the Oracle Database World with everything about the Oracle Database, with many live events and hands-on workshops as well, taking place on the 2nd and 3rd of November. And on the 17th of November, we have another workshop live on SailGP. So I'm not sure if you know what SailGP is, but it's the fastest boats on the planet. And also there, we're going to use machine learning to do all kinds of interesting things. And you can learn more about machine learning essentials and the products that we're using. So if you want to learn more, there's plenty of opportunities. So thank you, everybody that helped with this. There's a lot of people putting a lot of effort into this. Special thanks to Nada, to Mark Philippe, to John, but also to everybody else involved. And the biggest thanks, of course, goes to the audience. Thanks for your effort of trying to finish these exercises. I hope you enjoyed it. We'll be here a little bit longer to help you with some questions still. And hope to see you next time. Bye-bye.